So let's talk a little bit about Internet. What I'd like to start with are relatively recent statistics. This is a snapshot of the last 9 years of Internet's evolution. And in that 9-year period, the number of computers on the network has gone up almost by a factor of 20. The 395 million hosts that were estimated in the beginning of this year do not include computers that are connected from time to time. So a laptop like this one just got connected to the Internet. It's not counted in that 395 million. Those are the hosts that are on the network all the time. They're acting as websites, they're providing web services, they're providing email, they're providing other functions. They have permanent IP addresses, and they typically are also represented in the domain name system. If we were to count all of the equipment on the Internet at one time or another, this number would be at least double, possibly more. As far as the number of users goes, in that same 9-year period, we clearly have exceeded by a factor of 20 the number of people that were on the network 9 years ago. It's over 1 billion users, and it might be bigger than that. We don't know for sure because these statistics are obtained by surveys. We don't have a single registration point where every user in the Internet has to sign up and say, I'm a user of the Internet. In places like hotspots and in places like Internet cafes, users come and go, and it's hard to know exactly how many there are. But that's the current estimate. The other thing that's happened in the last 5 or 6 years in the telecommunications world has been an incredible flood of mobile telephones entering into the public switch telephone net. Almost 2 billion have been introduced into the system, which tripled the size of the public switch telephone net. There are about 1 billion wireline terminations and now 2 billion mobiles. A lot of those mobiles are Internet enabled, and so they represent a major new influence on the Internet's architecture and on the demands that are placed on the Internet's function. As far as the distribution of users go, you can see from this chart that the largest single block of Internet users are in Asia, and this region includes China and India, Indonesia, Malaysia, Japan. Really, about 56% of the world's population lives in the region that we call Asia, and 364 million of them are already online. If you look at North America and Latin America, in which I would include the Caribbean and Central America, the sum of North America and Latin America is just slightly over 300 million, so we're already outnumbered when it comes to Internet population. All this tells you is that over the next several years, we're going to see a significant increase in Asian users on the network, and therefore a significant increase in Asian content. So we will see a lot more material in languages that we may not be very familiar with here, in Chinese and Japanese and Korean and Hindi and Urdu, and many other languages that are spoken in the Asian region. So we should simply prepare ourselves for a very much more diverse network than we have seen even in the last decade. I would guess that by the end of this decade that we might see at least a doubling of the population on the Internet to at least 2 billion users. But today about a little under 16% of the world's population appears to be online. It's interesting to know where in the world we have the highest penetration of Internet use. And what you'll see from this chart, I think this is the top 28 countries in terms of Internet penetration. Malta, surprisingly, has the highest penetration of any country in the world, 78.3%. New Zealand is second, and this was actually quite surprising because Sweden used to be at the top of the list, and New Zealand surpassed them. Now, we just had an ICANN meeting in New Zealand, in Wellington, in March, and I made inquiries about the Internet population in New Zealand and learned that although it's a very high percentage, most of them get access to the Internet by dial-up, which today is considered to be a little slow. If you look at broadband deployment, New Zealand is actually not nearly as far along as places like South Korea, which have, and particularly Seoul, the capital of South Korea, which has the highest per capita penetration of broadband internet access of anywhere in the world. There is one interesting statistic here. If you look at the highest percentage of penetration, you'll see Iceland and Sweden, Denmark, Norway, what did I miss? Finland, are all the Scandinavian countries are on this list. And for a while we wondered, why is it that the Scandinavian countries have so many internet users? Until it was pointed out to us that the winter months in the northern Scandinavian countries last for a really long time, and there's nothing else to do but surf the net because they're frozen up there. I mentioned earlier that South Korea was a new addition to the high population internet countries. Hong Kong is another new addition, as is Singapore. And it happens that Hong Kong, Singapore, and South Korea also have extremely high broadband penetration. And one question is, why is that? It is speculated that one reason for the high penetration of broadband access to internet has to do with where people live in those countries. Most of them live in high-rise apartment buildings, and it's actually fairly inexpensive to bring fiber to a high-rise building and then provide broadband service to everyone in the building. And so if you've ever been in Hong Kong, you know that it's essentially a vertical city. Everything goes straight up. So there's a likelihood that broadband has gone into places where there's high-density housing more quickly than it goes into places where you have more single-family dwellings, because it's harder to deliver fiber one house at a time. So in the U.S. we have a relatively modest broadband distribution, and I suspect the same might be said here in Brazil. Now, this raised a question in my mind about statistics in the American countries, both North and South America. So I did a little bit of research, and this is what I learned, that of the 885 million people living in the Western Hemisphere, in North America, Central America, and South America, the distribution of internet users is still very heavily weighted towards North America, where 68% of the population on average has access to internet. As we move down into the other parts of the Western Hemisphere, we look at South America in particular. What we see is, of the estimated 370 million population, that 55 million are online, which is roughly 15%, and that's pretty close to the international average. On the other hand, if you look country by country in these locations, you see an extremely wide diversity of penetration. In the Caribbean, for example, some of the small islands have only 1.4% penetration of internet use, and some have 56% penetration. I think that might be Bermuda or Barbados, one of the two. In fact, if you go back to this list, you'll see that the only two Latin American countries represented are Bermuda and Barbados. And I see Bermuda is 61% and Barbados is 56%. So that explains this third line here that says 1.4% to 56%. In South America, the country's penetrations range from 2.7 to 35.7%. So Brazil is kind of in the middle at 15%. There's no question that we need to do some more here in Brazil to increase access to the internet. In fact, here's the specifics in Brazilian terms. You can see that the PC, personal computer penetration, is modest. It's 10.2% of the population has access to a PC, 14.5% access to internet. One statistic that does stand out here is that 44% of the population has mobile. And what that means is that in Brazil, it may be that the bulk of the population is going to experience internet through mobile access before they experience it through personal computers and laptops, and before they experience it through broadband. So that has a potentially significant impact on the kinds of applications that will be most readily available to Brazilian users, because if they have to get to those applications through mobiles, there are constraints with regard to display space and constraints with regard to data rate. So people like Google, or companies like Google, will be thinking very hard about tailoring services to meet a population which is largely accessing internet through mobile telephony. I put this slide in because I thought it represented an example of how determined some people are to get on the internet. This picture was taken by the vice chairman of ICANN, Alejandro Pisanti, who is the chief information officer of UNAM in Mexico City. That's a really big school. I visited there just this week, or past week, and I was told there are 250,000 students and 30,000 employees at UNAM. So I don't know how Alejandro does his job for ICANN in addition to doing his job for UNAM. But this was taken in Belize while Alejandro was on vacation, and he talked to this fellow Val. He started out with a coin-operated laundry, and he noticed that his customers didn't have anything to do while they were waiting for the laundry to get done. So he put in a Wi-Fi hotspot, and now they can do their email or surf the net while they're waiting for their laundry to get done. And of course he has other services too, like fax and photocopy, video rentals, and FedEx. So he's a very enterprising fellow. This is not an unusual scenario, though. It's very common for internet first to show up in an academic environment, and I think that's exactly what happened here in Brazil. Then you start to see internet cafes popping up, because the cost of having a personal computer or the cost of having personal access to the internet may be high enough at the early stages that it's just too expensive for most individuals. As a consequence, sharing of the cost through an internet cafe makes good economic sense. When ICANN met in Accra, in Ghana, about, I don't remember, 5 years ago, or was it only 2 years? 4 years ago.
2002.
Thank you, right. Some of us drove around the town and we counted 36 internet cafes in operation. So this is a very common kind of scenario to see, namely that you have shared access to the internet to keep the cost down. But as time goes on, the cost of getting online gets cheaper, either because the equipment becomes less expensive thanks to engineering experience, or because communication costs come down. So over time, people get more and more personal access to the internet. This is a project that I wanted to draw your attention to because it's another example of combining of internet service with other more mundane things like growing food. The Food and Agriculture Organization has a project which they call the Growing Connection. And it's a very appropriately named project because they've combined two things. You can see in the foreground here what looks like little boxes full of plants, and that's exactly what they are. They're plastic boxes about this deep. They're filled with peat moss or other kinds of material that you can put seeds into and grow food, typically vegetables like tomatoes and beans and carrots and Swiss chard and all these other kinds of things. What makes these boxes particularly interesting is that they are extremely efficient in their ability to grow plants. They are covered with plastic. Holes are poked into the plastic to allow the plants to come out, but the plastic prevents the evaporation of water. So these boxes are 10 times more efficient in terms of their use of water than growing things in open soil. Moreover, because you can move the boxes around, you can actually move them indoors. And if you have a climate where you really have winter, something that you don't experience much here, you could actually grow these plants all year round. So you actually produce a possibility of growing food in substantial quantities 365 days a year instead of being confined to certain growing seasons. So that's all intended to help food production in rural parts of the world. The schoolhouse in the background has been outfitted with digital cameras, digital telephones, personal computers or laptops, and a satellite access to the internet. The purpose behind the internet side of all this is to provide access to information to the people who are planting and growing food in the earth boxes. They might, for example, discover an insect pest, or they might discover a plant blight. They can use the digital cameras to take pictures of the problem, send those pictures through the internet to an expert, and get back advice about what to do. Of course, in addition to that, they have full access to the content of the internet. So part of the intention here is to mix together the information gathering capability of the internet and the potential educational opportunities that it provides together with its food production activity. I actually have a few pictures of some examples of people using the earth boxes in this case in Mexico. In Guadalajara, for example, here you can see the plants poking up out of the holes that are put into the plastic tops. Here's a classroom where they're learning how to make use of the internet for educational purposes. Here's a picture of another group in Jalisco, and also in Ghana there's another Growing Connection project in this school for the deaf at the Cape Coast. You can see that there's actually, this is pretty powerful. The quantity of food that can be grown in each earth box is pretty impressive. I actually have 3 of these in my house on the deck in the backyard, and we're growing carrots and Swiss chard and beans and tomatoes. I have to tell you, if you have kids, this idea is really very, very good. Some kids don't like to eat vegetables, but it's very interesting to see what happens if they grow their own vegetables. They have a very different attitude. That's my carrot. I grew that carrot, and I'm going to eat that carrot. So this is great. You get your kids to eat vegetables because they want to. Okay, so let me now switch to something a little more technical. When the internet was designed, one of the things that Bob Kahn and I knew back in 1973 is that we did not know what new communications technologies would be invented in the future. But we wanted every one of those new technologies to support the internet. So we basically said that we would design the system so that it would not be very sensitive to the underlying transmission and switching system at all. That was the whole idea of layering in the structure. So the lowest layer in the internet architecture is basically the hardware layer that carries bits from one point to another. The next layer is up. Link layer organizes those bits into frames. And the next layer up is the Internet Protocol layer, which is basically the network function. That layer treats the bits as packets of information that look kind of like electronic postcards. And so if you needed a simple model, a metaphor, to think about how the Internet works, think about postcards and what you know about them, because everything you know about postcards applies to internet packets. For example, when you put a postcard in the post box, there's no guarantee that it comes out on the other side. That's also true of internet packets. If you put 2 postcards into the post box, there's no guarantee that they come out of the postal service in the same order that you put them in. Now, internet actually does something that the postal service doesn't do, as far as I know. Sometimes when you put an internet packet into the internet, 2 packets come out the other side, because they've been replicated and retransmitted and sent by different paths. As far as I know, that's not a service that the post office offers. So you might think, well, gee, how could the internet possibly be useful? It gets things out of order, it loses things, and it duplicates things. So that's why we have layers of protocol, because the next layer up is called the Transmission Control Protocol, or TCP. And that thing puts everything back together in the right order, retransmits things that have been lost. So together, those 2 protocols form the core of the basic internet. What's very important, though, about the architecture is the insensitivity of the design to the underlying transmission systems. It's also the case that the internet packets themselves don't know what they're carrying. So they don't know if they're carrying video or voice or a piece of a web page or part of an email. So this segregation of the underlying transmission system from the applications that are supported by packets is a really important layering construct in the internet, which leads to another important concept, and that's the end-to-end principle. In that principle, the internet says, I don't really want any knowledge of applications to be in the core of the network. So the internet service providers, for the most part, don't know what applications are running through their networks. And they don't want to know. They don't need to know. That allows a lot of innovation in the internet because you don't have to get permission from an ISP to implement a new application. You just start ejecting packets into the network or injecting packets into the network that carry the content of that application. So it could be video transfers, it could be a web page that you're transmitting across the net, it could be a Google search lookup and you're getting the answer back. As far as the network is concerned, it's just a series of packets that are being exchanged from one end to the other. That principle, that openness of the internet has stimulated a huge amount of innovation over the last decade. New business models and new applications come up all the time, and they are generally not produced by the ISPs, they're produced by people who have creative ideas at the edges of the network. This design has implications for regulation. I'm not an expert on regulation here in Brazil, but I can say that in the United States, the regulatory structure has tended to be very vertical in its character, and it has been very sensitive to the underlying transmission system. So we have one regulatory regime for telephony, which is mostly carried over twisted pair copper, not counting fiber in the core. We have radio and television over the air. That's regulated differently from telephony. And we have television over cable. That's regulated differently from the other two. The internet comes along and it cuts through all of that and says, well, I don't really care if the packets are carried over cable, over optical fiber, or over radio. It's just packets. And I don't care what the application is. It could be radio, or it could be audio, could be video, could be text. But I don't care. At the network layer, they all looks the same. So really, we should be regulating horizontally instead of vertically. So in the United States, where the Telecommunications Act was rewritten in 1996 without any concept of internet, we now think 10 years later it's time to start over. We need a new regulatory regime that takes into account the way the internet works. I've mentioned broadband services already. I just wanted to make some observations about them because they have implications for the applications that the internet can support. It's very common to use either cable television plant or digital subscriber loops to deliver broadband services to consumers. Both of those technologies have a very bad property, namely that they are not symmetric. What I mean by this is that typically DSL and cable broadband access to internet gives the consumer the ability to pull information in at much higher rates than they can push it out. So it's very asymmetric. For most internet applications today, that's perfectly okay because most people download more material than they send out. But over time, I predict that people are going to accumulate more and more digital information which they produce themselves that they are going to want to share with other people, and they're going to need the ability to push the data out at the same rate that they pull it in. So broadband services are going to have to become symmetric. Today they're not. There are some other technologies, some of which have been demonstrated in the recent years, that may be alternatives to cable and DSL. In Mexico, I was told that successful broadband communication over the power lines have been demonstrated, and we've seen experiments in the United States and a few places similarly. Radio is also turning out to be an extremely useful alternative to wireline communications for broadband. Of course, in many local hotspots, you'll see 802.11 Wi-Fi being used, but it typically only serves a small, short distances of a few hundred meters. There are larger footprint broadband services like WiMAX that will reach over tens of kilometers. There's a company called Gigabeam which supplies up to 2.5 gigabits per second of radio access over 1 to 2 miles. And so it's actually pretty powerful for short haul, last mile or last kilometer services. Of course, in the end, if you really want high speed, a fiber will give you a substantial amount of capacity, but it's costly to put fiber into every single individual house. So I believe that broadband services, first of all, will have to move towards symmetry, And second, that no one specific technology will be the solution for everyone's broadband needs, and that we will see a mixture of broadband access emerging. I've already mentioned that there are some 2 billion mobiles that are in use in the public switch telephone net, and a significant fraction of them are internet enabled. I know that everyone here must be using short messaging services of the GSM telephone network. One thing that I find interesting about these devices, this happens to be a BlackBerry, but the others are similar. When mobile phones were first built, that's all they did was mobile telephony. The first mobile I ever saw came from Motorola. It was a phone about this tall, and it weighed at least 3.5 pounds, and we called it the Brick, because it weighed about that much, and it was about that size. I actually have one in my basement. I acquired one of these for $3,000 in 1982. I don't know if it still works, actually. I haven't tried it. The difference between the Brick and this piece of equipment is that this is a computer. It's programmable, it has memory, it has a radio, obviously, and it has a small display and a keyboard, suitable for people who are 3 inches tall. So these programmable devices have the property that if you find new software that you can download into them, they will do something new. So these are very malleable devices, and you're seeing exactly that happening in the mobile world today. Short messaging systems are an example of a new application. Payment systems are starting to show up in mobiles. You can actually initiate a transaction, transfer money by way of a credit card, or transfer money from a bank account from one place to another using your mobile. The other thing that's happening is that these are being equipped with global positioning satellite receivers. And so now this device knows where it is. And once you know where you are, then you can start asking questions that wouldn't make any sense unless the system you were asking the question of knew where you were when you asked the question. So this gets to the interesting possibility of having geographically indexed data available to you in order to answer questions such as, where's the nearest hospital? Or where is the nearest churrasco? Or is it churrascaria? Where is the nearest gas station or ATM machine? You can't get an answer to that question unless the thing you asked the question of also knows where you were when you asked it. So if you were sending a query with one of these devices saying, where's the nearest ATM machine, if this sends the information about where you are along with the text of the question, that's an answerable question. And the host on the internet that gets the question from you can go find a geographically indexed database of ATM machines and say where they are relative to where you are now, or at least where you were when you asked the question. Well, that, I think we'll come back to this geographically indexed information in a minute, because I think people who have knowledge about where things are or what is going on in certain places will derive a lot more value in the future from that knowledge than they could in the past. Convergence is a term that is often applied to the convergence of the internet and the telephony world. I suggest to you that convergence is a much broader notion, because the internet now shows that it can carry all media, whether it's video or audio, radio, and so on. Internet's capable of carrying it. It's just bits that have been cut up into packets. So some of you may already have been using, or maybe you have children who are using something called instant messaging. This is just typed messages, text messages going back and forth like the SMS in the mobiles. The reason I bring this up is that when the instant messaging application got started, it was just a question of knowing whether your friends were online or not. And that's a very binary notion of presence. Either you're there or you're not there on the network. If you are there, you could double-click on an icon and open up a window and type to your friend. That very binary notion of presence has gotten much more nuanced than in the past. Here's why. If you're sitting here with a laptop and you're typing at some friend who's on the other side of the network, with a small change of software, you can take the microphone, which is built into most of these laptops, and use it to digitize voice and talk to the person on the other end. And if you happen to have a television camera that's plugged into this thing, or even built into it, Another small change of software lets you take the video image and digitize it and packetize it and send it through the net. And if you chose, you could activate a piece of software that allows you to collaborate with your partner on the other side of the net or with multiple people. So the point I'm trying to make here is that the notion of instant messaging now is a very rich panorama in which small changes in software lead us from text exchange to voice exchange to video conferencing to collaborative tool use. So the idea of presence now could become very, let's say, nuanced. You might decide that you're willing to be present for interactions to a fairly large audience for text purposes. You might be willing to interact textually with someone, a large number of people. You might be willing to speak to a smaller number of people and perhaps have a video conference with an even smaller or different set of people. And for yet another class of people, you might be willing to have a collaborative software interaction. So you can imagine presence no longer being simply binary. It's now a kind of a function of the modality with which you're willing to interact with some other party. This, by the way, the notion of presence here shouldn't be confined only to people. There's no reason why you couldn't have a program on the other side of the network that you're interacting with. And in fact, it can even go so far as two programs discovering each other on the internet and exchanging information to carry out some function. So presence can be quite diverse in its interpretation. Implicit in what we've been saying is that carrying sound over the internet is just another application of a network. It really has no additional incremental cost beyond simply being on the net with a device. This is bad news for companies whose basic business model was making phone calls and charging you for it, because there's no incremental charge for, or need not be an incremental charge for sending voice across the network. So voice over IP is actually a fairly terrifying prospect for a company whose principal business model is getting people to pay for telephone calls. My reaction to this is get over it, because that's basically what the internet does. It provides for an alternate way of doing old things with a very different kind of economics. So we are going to see, I think, telephone companies having to change their business models in order to respond to the challenge that internet places on the table. Another thing which is pretty visible right now is that the various media, whether it's radio, television, movies, or print material, all of those media are moving towards digital production. There are a number of reasons for that. One of the major reasons is that digital is flexible, and it takes advantage of the economics of digital transmission and storage. I did a little calculation not too long ago. In 1979, I bought 10 megabytes of disk storage for $1,000. And recently I checked to see how much storage I have at home, and it's a terabyte of disk storage. So I thought, how much would it have cost me in 1979 to have a terabyte of disk storage? And if you do the arithmetic, it's $100 million. Well, I guarantee you I did not spend $100 million on my terabyte of disk storage. Even if I had $100 million, I'm sure my wife would have had a better use for it than me buying disk storage. So I, in fact, only spent $1,000 for that disk storage. So that means that the cost of disk storage has come down by a factor of 100 million, basically, in the last roughly 25 years. So storage has gotten cheaper. So has digital transmission. And that economic change has had a dramatic impact on what we do with digitized information. There's another thing which bugs me no end. That's a technical term. It has to do with the limited understanding that some companies have of what digital video means. Many of them think it means real-time transmission of video in the same way that the television appears over the air or on cable. And I would like to argue with you that that's really too narrow an understanding of what digitizing video really means, or for that matter, digitizing anything really means. If you're trying to deliver stuff in real time, it's a big challenge for a packet switch net. The packets have to show up in the right order. They have to show up with not too much inter-arrival time variation, or the image or sound will break up. But suppose that you didn't watch or listen to the transmitted data while it's being sent. Suppose you downloaded it and listened to it or watched it later. Well, then the transmission is easier. It doesn't even matter if the packets come out of order. You put them all back in order before you play it back. Well, there is a generation of internet users who understand this implicitly. They are the iPod generation. They download music from Apple and they play it back later. This is actually important for several reasons. One of them is it's a lot easier function for the network to perform. And you'll notice that you can do these kinds of file transfers slower than real time or faster than real time. Whereas if you insisted on watching it while it's being transmitted, it has to be exactly in real time. If it's slower than real time, it just takes longer. But suppose you had gigabit access to the internet, which you can get, by the way, in Sweden, in Stockholm, for about 100 euros a month. You can get 100 megabit per second service in Tokyo from NTT East for $50 a month. If you had a gigabit access to the internet, you could download an hour's worth of HD TV in 16 seconds. Now, video on demand is often thought of as real-time video, and I'm here to tell you video on demand may be downloading an hour's worth in 16 seconds, then watching it later. Now, why is that so important? Well, I want you to think for a minute about what it might be like to download video in packetized form. Let's suppose I've got an hour's worth of HD TV, and I'm downloading the stream of packets, and of course I'm storing them on my cheap disk storage. That stream of packets does not have to be limited just to video and audio. There's no reason why it couldn't also include things like information about the movie I'm about to watch, or a book that's associated with that movie, or maybe it's a program that I can use that's associated with the entertainment, or maybe it's an educational movie that I'm going to watch. So it even could include advertising. So this stream of stuff that I download, which I'm going to watch later, can be a very diverse mixture of material, and the thing that receives it, the computer that's taking all this data in, can look at the packets and decide where to put them and how to categorize them. Okay, so now it comes time to watch whatever it is that I'm watching. And I'm pulling the packets up off the disk. The device that's doing this is not a stupid raster scan television set, it's a computer. So the computer can actually look at what it's doing and decide how it's going to manage the screen. And so part of the screen could even be reserved for some icons that you could click on if you wanted to. So suppose you're watching this program, and you're interested in finding out something about what's going, what's behind the program. You could click on an icon or two that has been set up to trigger the transfer of data off the disk to show you what the background material is. Or maybe you just freeze the image and you move the mouse around in the image on the screen that's frozen and click on various things in the scene. Like, what if you saw a product that you were interested in that movie, and you clicked on it, and the system said, well, I know about that product. I downloaded some information about it earlier, and it pulls up a window that says, well, this is a Ford Motor Company car, or a General Motors car, or it's a nice suit that came from Brioni, or some other thing that you might be interested in. Advertising opportunities with this new medium are quite richer than the ones we have today. You no longer have to force advertisements on people. You let them decide what they're interested in. I can tell you that the advertising industry is having trouble adjusting to the idea that the consumers are in charge. In the past, they've always been in charge of pushing things in front of you, whether it's in the newspaper or a magazine or interrupting a television program or a radio broadcast. Now suddenly the consumers are in charge. They decide what to download, they decide what they're interested in, and they decide when they're going to look at an advertisement. Google has understood this pretty implicitly because that's how we generate our money. People click on the ads that we put up. We don't force them to click on anything. They choose to do that. And the fact that they chose to do it makes those ads more valuable to the advertisers, which is why we have had a very successful business model. It's generated a lot of revenue in the last 8 years. In fact, our past year was $6 billion a year in online advertising. So let me just mention one other thing about economics. We already discovered that disk storage was cheap and data transmission was cheap. Suppose you wanted to go into the business of delivering DVDs, television DVDs to people, and you had 200,000 titles. So you have to have at least 200,000 DVDs in your store if you were going to build this in the real world. Maybe more than 200,000 in case more than one person wants the same DVD. How many stores would you have to build to reach a reasonable market? Well, I don't know. You might have to put several of them up here in Sao Paulo because this is a really big city. And it's going to cost you money to build the building, to pay the rent, to copy the DVDs, and to make them available, staff the store with people. It might be so expensive that it wouldn't make any sense for you to have this big inventory. Maybe the only thing you could afford to do is have inventory of the most recently released video entertainment or audio entertainment. If instead you build a virtual store and you put one copy of every DVD and CD into memory on the net, and you offer to people to come to you virtually through the internet so you can download any of the videos or any of the CDs you want, suddenly you have a potential user base of, what, 1 billion users around the world. And you don't care where they are. They come to you over the net. The business model of a virtual store is infinitely better than the physical business model. And so right away you can see that you could service customers whose interests are in old movies and old music just as easily as people who are interested in the most recent releases, because from your point of view it costs exactly the same. So you get to harvest a much bigger market for video and audio entertainment than you could in the real world. Now, having said all that, I have to tell you that there is a store, or a company in the U.S. called Netflix. Netflix lets you register to get DVDs through the mail, through the postal service. And my wife is a big fan. The way they do it is they say that you can sign up for $20 a month and have as many as 3 DVDs at a time. You have to return the DVDs through the postal service before you get the next one. So there's a little stream coming to you of up to 3, or maybe you can have more than one account, or you can pay more money and have 5 DVDs in use at a time. Why is this so interesting? Well, first of all, it wouldn't work except that you can go on the internet to place the orders. They have something like 60,000 DVDs available, physical DVDs available. And you get to order them through the net. They tell you when they've shipped them. They tell you when you send them back through the postal service. They let you know that they got it back. So all of the customer service and interactions and ordering happen on the network, but the physical delivery happens through the postal service. Now, personally, if someone had come to me and said, I'm going to start a business like that, I would have said, you're crazy. So I called the president of the company, Ken Hastings, and I said, Ken, how many DVDs are you shipping every day? 1.7 million DVDs a day go into the postal service. So I got to thinking about that. Let's see, 1.7 million times 5.7 gigabytes per DVD divided by 86,400 seconds per day is a pretty good data rate. This guy has built a very high-speed transport system out of the U.S. Postal Service. And, you know, I'm sitting here shaking my head. But I did remember that someone told me that the highest data rate transport known today is a 747 full of DVDs, right? It takes a little while for it to get from the beginning to the end, but the data rate throughput is really impressive. So this guy invented a business that only would work because he took an old system, the Postal Service, and linked it to the Internet. And the two together created something that could not have been done separately. Okay, so this is just a screenshot of a new application called Google Book Search, and I bring this up simply to say that one of the things that Google is interested in is trying to organize the world's information and make it accessible to everybody. An awful lot of the world's information is locked up in dead trees, in paper. And so we would like to find a way to make that paper more discoverable for people. I would like to distinguish here between delivering the contents of a book online, which is one thing, and having an index of a book which helps people find the books that might be of interest to them. Those are two very different things. Our focus here is on creating indices of books so that people can learn which books have information of interest to them. So when you do a Google search today of the web and you put in various search terms, we try to find websites that have those terms in them. The Google book search tries to find books that have those terms in them. And so we report back to people, if you are interested in these terms, the following books have that data. It would be nice, of course, what did I do? Did I get a, okay. It would be nice, of course, if some of the books could actually be delivered online. And for all the books that are in the public domain, which probably is, roughly speaking, anything published before 1894, then we would scan the images and make them available because they're public domain. We have business relations with the publishers who have current books in print. Of course, they clearly have copyright ownership of the books, and the arrangement we have with those publishers is that we will present as much of the book as they're willing to let us put up on the screen. Sometimes they will only let us put up a little sentence or two around the terms that you were searching for. Sometimes they let us put up the first chapter of the book, and sometimes they say it's okay to put little snippets of the book up, except in no case can you put anything from the last 10 pages. This would be typically a mystery novel or one of those thrillers, so that you can't find out how it all turns out without buying the book. So in the end, we tell people about books that exist, and then we say, well, if we can't deliver the book to you, here are places where you might find it. You could go to Amazon, you could go to a library, you could go to a friend and borrow the book, and go downtown to a bookstore and buy it. So our purpose here is to try to open up the world of print material to online discovery. So now, has everyone here already seen Google Earth? I mean, if you have, then there's probably not much point in my demonstrating it to you, even though I'm all set up to do that. What I did do is a few screenshots that we pulled up from this region. Sao Paulo in particular is seen from 35 miles high. Then we tilted it down to get a more perspective view of what it looks like from about 14 miles. Then we shot a few closer, we zoomed in and shot a few other things. Here's Rio, which I assume you would recognize better than I would. This is actually an overhead shot of the area where I live in Northern Virginia, and in the upper right corner here is a very big shopping center called Tyson's Corner Mall. And the reason I'm putting this up is that I happen to know that we have recorded a substantial amount of information. I mean, you can't read this very well, I'm sure, but these are the names of restaurants in that area. A lot of the references are from our users. So Google didn't go and check every single restaurant in Tyson's Corner Mall, but we built a standard interface that the users could use to inject information into our system about the restaurants that they learned about, or about the businesses, or about the other places of interest in the area. So what we tried to do here was to allow the users of Google Earth to share the information that they have with everyone else in the world who might care about restaurants in the area. And so every time we're not live right now, so I can't actually do this, but if you click on the icons associated with a restaurant, a little window opens up, and it has information in it about what's interesting about that particular restaurant or that particular business. What this is essentially trying to do is to augment the information we have that's geographically indexed. And so it's another example of monetizing geographically indexed information. In Google Maps, which I'm not going to show here, when we actually present the information on the screen, we reserve a little bit of space for advertising. And so the cost of providing the access to Google Maps is offset by the revenue generated by the advertisements. We haven't done that with Google Earth, and I don't know whether there's any plan to do that, but it's clear that somehow all the costs of doing these sorts of things has to be paid. This is just tilting the image down again to get a perspective view. So let's talk a little bit about the business models that these various parameters, these economic parameters are creating. Online advertising is not new. Several companies have tried it in the past. Google has been among the more successful of the companies to make this work. And the reason that I think it's worked so well is that the advertiser doesn't pay unless someone actually clicks on an ad. Now, if you've been paying attention to some of the issues that have arisen in this area, you know that one of the problems we have is called click fraud. People write programs that go and find advertisements and click on them. And typically you find somebody, a competitor, clicking on his competitor's ads. And that causes the competitor to spend money on the ad because they have to pay us every time somebody clicks on it. And of course, nobody was looking. It was a computer program. Well, that's click fraud, and we try to detect that by observing what IP address was clicking on the ad, and if it's the same one that clicked 300 times a second, we figure no human being would bother doing that. If the advertiser says somebody is defrauding me, we look into that and we'll reimburse whatever charges there were. But you should know that there are programmers in the background trying to find algorithms for detecting this kind of abuse and essentially not charging people for it or trying to defend against it. I admit to you that when I joined Google in October, I was a little nervous because the company had been going for 8 years, starting with 2 people, and had grown to 6,000 people. It had grown to $6 billion a year in revenue in that amount of time, and I thought, gee, I wonder if we're, kind of close to the limit, and, if I just joined as it's topping out. So I said, how big is this business? And they said, well, the U.S. data is that for all advertising, print, radio, television, and promotions, it's $420 billion a year. And I thought, well, we're only getting $6 billion of that. There's a little room left for us to grow. The other thing that's worth observing, I think, is that as online advertising is shown to be more and more effective, if we can demonstrate increasing effectiveness of online advertising, that some of the budget that has been going to print media, television, and radio will shift over into online modes. The other thing that I think is very important here is to understand the possibility that these different modalities for advertising can become mutually supportive. How many times have you seen a television ad telling you about a book, or an ad in a newspaper telling you about a movie, or an ad on the radio telling you about a newspaper? And so what you see is these different modalities of advertising are pointing at each other, trying to mutually reinforce the messages. So I can see online advertising becoming another element of that mutual reinforcement. We've recognized fairly clearly that we don't have a corner on creativity at Google, although we have a lot of very creative people. So we've been opening up standard interfaces to most of our applications to allow third parties to add value. An example in Google Maps, one very enterprising guy in Dallas, Texas, compiled a big database of knowledge about apartments in the area. Things like how big was the apartment, where was the apartment located, what schools were nearby, what other amenities were available. And you could type into the web interface the parameters that you wanted in an apartment. And he would present on the screen little icons for every apartment that matched your requirement. And when you clicked on the icon, it opened up to tell you more details about the apartment. Well, he used Google Maps to present the information. And, of course, that attracted a number of people. And since we had little advertisements on the Google Maps system concurrent with presenting the results of the apartment search, we generated revenue from that. And we shared it with the fellow who had the database. So we've got a mechanism going to allow parties with information to generate advertising revenue as a consequence of that information, and we share it with them. Now, since you're sitting here in NIC.br, I added one more point here about the domain name system, which surprised me as an engineer. The domain name system was originally designed as a way of pointing to things in the internet. So you could find a website or a host that would perform a service for you or would receive email that you had sent. But it turns out that the domain name system has generated businesses that I never anticipated, and maybe some of you didn't either. including what is now called typo squatting. These are registrations of domain names that are misspelled. And my first reaction to this is, why would anybody want to register a misspelled domain name? And the answer is because people type misspelled domain names into the browser windows when they're trying to do http:// domain name. And the people who register these mistyped domain names then vector the ads to what's sometimes called a domain name parking lot. That web page contains a bunch of advertisements on it. And so if you mistype the target domain name, you end up on a web page full of advertisements, some of which are supplied by Google. And if the party who mistyped the domain name actually clicks on one of the ads, it generates revenue. So the people who own the domain names actually get some of that revenue. Some people in a meeting in Seattle about 2 months ago who own over 1 million domain names personally. And the first time I met somebody who owned 500,000 domain names, I was sort of stopped in my, stunned, thinking, what does anybody do with 500,000 domain names? Well, the answer is they park them on the parking lot and they wait for people to click on them. I don't have time to go into all the details, but the domain name, secondary domain name business, which is a consequence of this advertising model, has become a very, very active piece of the domain name business. And one of the questions I'm going to be raising later is whether or not that's visible here in Brazil, because it's definitely visible in the generic top-level domains, especially .com. Well, I'm not going to go through all of these things here. There's a long list of issues that we are still having to address in the internet world. Things like internationalized domain names. These are domain names whose script is other than Roman characters. This has been a very long process to introduce these other scripts, but there are many, many people for whom it would be much more pleasant and effective to interact with the internet using their native languages, which are not expressible in Roman characters. Now, here we don't have that problem because you speak Portuguese, and that's easily expressed in the Roman character set. But if you happen to speak Cantonese or Mandarin, or if you speak Korean, or one of those other languages, Hindi, you would like to have a very different character set than what we have supported today. And you'd like the domain names to be completely and fully expressed in those languages or in those scripts. We found it to be actually quite hard to introduce all this, and it's not just technically hard. There are side effects associated with registering domain names in scripts other than Roman characters. If you happen to speak a language that's expressed in Cyrillic and you want to register a domain name, Russian would be an example, you might reasonably expect that when you contact the registration place that they will speak Russian, because you expect to be able to interact in the language that you're registering the domain names. Some registrars were daunted by the thought that as soon as they introduced these new scripts, they would also have to have people available who could speak the languages to interact with these customers. And some of them weren't sure that that was going to be economically possible. There are also a lot of technical issues associated with trying to place these extended character strips into the domain name system itself. So without going into a lot of detail, this is turning out to take a long time. New top-level domains is a huge issue because figuring out under what circumstances you should accept a new top-level domain and authorize it has turned out to be a harder problem than anyone expected, certainly harder than I expected. The policy issues associated with who's allowed to introduce a new top-level domain still are part of the policy development process at ICANN. I promised I wasn't going to go through every one of these. I want to mention IP version 6, partly because I have a continuing concern that the current IP version 4, which was standardized in 1978, will eventually run out of address space. It hasn't yet, but it only has 4.3 billion unique addresses. That's less than the number of people there are in the world, and I'm predicting there will be a larger number of devices on the net than there are people, all of which will need IP addresses. IP version 6 has 128 bits of address space. That's 380 trillion addresses. which should be enough to last until after I'm dead, and then it's somebody else's problem. So I'm a big proponent of getting IP version 6 in place and pushing very hard to get there. The Internet, as it's expanded, has produced all kinds of public policy concerns. For example, intellectual property protection. People get copies of movies, for example, or audio CDs, and they put them up on the net illegally because it's a copyright violation. And so the producers of those things are quite concerned about abuse of the digital transmission capability of the Internet. And in some cases, they run away from the technology hoping that it would just disappear. That fear is now transforming itself into a tactic to try to make use of these new technologies. So to give just one example, there's a peer-to-peer application called BitTorrent. BitTorrent is a very highly distributed mechanism for moving large files around the network. Frequently, those large files in the past have been pirated movies. And so the intellectual property community quite rightly associated BitTorrent with illegal copyright behavior. Recently, they've actually cut business deals with BitTorrent to use the technology to distribute movies that have been encrypted. And you don't get to do anything with the movie until you buy a key to decrypt it and watch it. So I'm seeing an increasing awareness in the community that you can't run away from technology. If you're smart, you'll figure out how to use it. And we're starting to see that happen. So I'm not going to go through the rest of this for now. I do want to mention that there was a recently concluded 4-year period of discussion on the subject of the information society, whatever that is. And that's exactly what they were asking themselves. What is the information society? And in the course of the discussions, the countries that were meeting chose the Internet as a kind of prototype of a substrate for an information society. And like all governments, they then said, well, this is a pretty big distributed system. Who's in charge of the Internet? And we said, well, nobody, really. It's a very distributed system. And they wouldn't believe us. No system could be this big and important and not have a central control. So they started looking around for a central control for the Internet, and they decided that the Internet Corporation for Sign Names and Numbers must be the center of control of the Internet, because it was the only organization that did have some central responsibility. Well, ICANN is responsible for simply trying to make sure that the domain names that get allocated are unique, and that the Internet addresses that are allocated are unique, and that the parameters that are used in the protocols of the Internet are also unique. That's it. That's the only job it has. It doesn't actually deliver or register domain names for anyone. It assigns responsibility for top-level domains to qualified institutions. NIC.br is an example of an assigned top-level domain, .br, which ICANN has delegated to NIC.br to operate. And we also allocate big blocks of Internet addresses also to in this case, to LACNIC in this region. And LACNIC, which is operated by NIC.br, then allocates those addresses to ISPs and others who qualify. Well, so ICANN became the core of a hurricane of debate and discussion about Internet governance. There was a lot of complaint that ICANN was a non-profit in the United States, and it really should be replaced by the International Telecommunications Union. And I hope I won't offend anyone by saying sometimes I think the ITU doesn't know how to spell IP, let alone operate the functions that ICANN is responsible for. So obviously, as chairman of the board of ICANN, I'm not an enthusiast for transmitting or transferring the responsibility to this august but increasingly irrelevant institution. The end of the World Summit on the Information Society concluded leaving ICANN in place with its responsibilities, but it created an Internet Governance Forum, which is a multi-stakeholder group responsible for continuing the discussion about Internet governance. Now, this, I think, is potentially very positive and constructive. The reason I think this is that there are a whole lot of issues associated with Internet which ICANN has absolutely no authority to deal with. Fraud and abuse on the network, the problem of law enforcement in international settings, the question of legal frameworks for electronic business over the Internet. None of these are within ICANN's purview, and yet they are vital to the use of the Internet as an economic element. So I hope that the Internet Governance Forum will in fact begin to focus on some of these issues which have not gotten adequate attention in the past. I'm going to skip over this slide given the lateness of the day. I do want to make one comment, though, about infrastructure. Many people, when they talk about infrastructure, focus on the physical manifestation of infrastructure, the networks, the road system, personal computers, and things like that. They often are hoping, by creating that infrastructure, to reproduce things like the Silicon Valley effect in the U.S., where there has been such an explosion of entrepreneurial success. Companies like Yahoo and Google, eBay and Amazon and so on are products of things like the Silicon Valley. The real question is, what are the ingredients that lead to that kind of economic growth? And the answer is it's more than just personal computers and telecommunication services. I don't know if you remember in history this fellow named Potemkin, who used to take the Queen of Russia around on trips, and he would show her these beautiful villages in the distance to assure her that the economy and the peasants were prosperous. Now, actually, these were villages made out of wooden facades. There was nothing on the other side of them at all. And my worry is that people who don't think broadly enough about infrastructure will build the equivalent of information technology Potemkin villages. They'll invest in a whole lot of physical facility without realizing that it won't do anything unless, for example, you have a trained workforce, unless you have the ability to support that system, unless you have creative ideas for applications, unless you have access to capital so that you can begin new businesses. One thing I've learned in the last 30 years is that most of the jobs that get created in the world are from small businesses. Not from big companies, but small businesses with ideas that work. And so you need to have the freedom and flexibility to create new businesses. And if you don't have support for that with seed capital of some kind and sustaining support, then it will be very hard to actually create an economic engine that uses the PCs and the communication systems to grow the economy. It's also important to notice that electrical power is needed to have a successful information technology industry. If you don't have reliable power, this gets really hard to do. And if you talk to the NIC.br people, they'll tell you about the multiple ways in which they make sure that electrons come into this building to keep all of the systems running. And the final thing I'd observe about infrastructure is that if the telecommunications policy inhibits that end-to-end principle that we talked about earlier, if it prevents people from trying out new ideas by constraining the applications that they're allowed to implement, then you are going to kill the fertility of the infrastructure that you're trying to create. And we're having battles around the world with the incumbent telecommunications carriers, some of whom are unwilling to understand the transformation that internet technology is making in the business sector. Some of them are saying, we built this broadband network and we can do anything we want to with it. And if you want to compete with us, too bad. You have to pay us extra to do that, or we won't let you do it at all. We're going to interfere with your traffic because we want our consumers to get our services and not yours. This is an example of killing innovation. There's been a big fight in New Zealand, which was over, and in the end, the decision was made to open the network up to make sure that it was accessible to anyone who wanted to offer services on it. The same thing happened in the Netherlands. The same thing happened in the UK. British Telecom has been told to open the network up. And I'm fighting the same battle in the United States. In fact, I'll be appearing before congressional committees next week to debate this point. So I strongly recommend that open access to the broadband facilities be maintained in order to assure that we have innovation in the system. Now, I could stop here, but I will ask you whether you want to report on OG. Why don't we do this? I won't, unless you want me to, I won't go into the interplanetary internet. But I did want to mention one other thing about appliances on the network. I have been stunned to discover things on the net that I never anticipated would be on, like refrigerators and picture frames. But the guy that really got me was this fellow in the middle. He was a surfer, S-U-R-F-E-R, in San Diego. And apparently while he was sitting there waiting for the next wave, he thought, you know, I could be surfing the internet while I'm sitting on my surfboard if I had a laptop built into the surfboard and a Wi-Fi connection going back to the rescue shack. So he built a surfboard with a laptop in it. And now he sells this as a product. So, and the other thing that caught my eye is these RFID devices, radio frequency identification devices. They get used today to let you go through the toll roads without having to put money into the apparatus. They just detect your account number and decrement it. So I got to thinking that RFIDs, if they got cheap enough, could be put into product packages. In fact, one big store in the United States called Walmart was starting to push the idea that its suppliers should put RFID chips in the packages that they sell to the public. That's actually potentially a good thing, especially for products that have a short shelf life, medicines, for example, and perishable foods. You could send a single radio pulse in the store and get back a list of all the things on the shelves so you could tell which ones should be removed because they'd exceeded their lifetimes. Or if you were in a hospital setting, the patients could wear a little plastic wrist tag with an RFID chip in it, and you could check the RFID chip against the medication that's being given to the patient to make sure that these are properly matched. So I got to thinking about what was going to happen on the internet in the future, and I've concluded that there are going to be billions of internet devices that are online. Some of them we see already, like web TVs and Palm Pilots and Blackberries. Most of them will be programmable in high-level languages. It's amusing to start to think about what you can do with an internet-enabled device. So I thought about an internet-enabled refrigerator, which, by the way, you can buy now. It's a high-end product. It has a liquid crystal display on it, a keyboard, and a touch-sensitive panel. But I thought, what would happen if you put an RFID detector in the refrigerator? And so every time you put food in there, if it has an RFID chip in it, the refrigerator knows what it has in it. So while you're working, it's surfing the net looking for recipes that it could make with what it has inside. And when you come home, you see a list of recipes that you could make with what the refrigerator has in it. So then I thought, well, there are other scenarios. You're on vacation, and you get an email, and it's from your refrigerator. And it says, I don't know how much milk is left in the bottle, but you put it in there 3 weeks ago, and it's going to crawl out on its own. Or maybe you're at the supermarket, and your mobile goes off. It's an SMS from your refrigerator. Don't forget the marinara sauce. I have everything else I need for spaghetti dinner tonight. So, the problem with these scenarios, of course, is that somebody messed them up. The Japanese have invented an internet-enabled bathroom scale. And so when you step on the scale, it figures out which member of the family you are, and it sends that information to the doctor to become part of your medical record. Well, that's okay. The trouble is the refrigerator's on the same network, and it gets the same information. So when you come home, you start seeing diet recipes on the display. Or maybe it just refuses to open because it knows you're on a diet. This is terrible. Let me pick, there are lots of more things here than I have time to talk about, but let me ask you, you must all have entertainment equipment at home. And probably that entertainment equipment has a remote control. And if you're like me, you have several remote controls. And the first problem is figuring out which remote control goes with which device. And then after you figure that out, that's the remote control with the dead battery. So I propose that we put all of the equipment on the net, assign IP addresses to all of them, including our mobiles, which now become our remote controls. Now the cool thing about this is that you don't even have to be in the same room in order to interact with these devices. Anywhere on the net is fine. You could be anywhere in the world and still control and manage your internet-enabled entertainment system. Of course, we better make sure you have good quality authentication. Otherwise, the 15-year-old next door will reprogram your house while you're away, and that's not what you had in mind. But the idea that you can now interact with these devices anywhere in the network also introduces another business possibility. You could imagine offering to someone a management service that would manage his or her entertainment devices for them. So you interact with a web page to this server on the net, saying which videos you wanted to download and which music you wanted to listen to, and that computer would manage all of your devices for you. So I guess, at least I hope, that we'll see these little mobiles turn into a universal remote control. Then we only need one. And since we're so dependent on these already, it probably won't have a dead battery. All right. So, sorry? You want to know about the socks? Okay. Well, you know, the medical world has now started making clothing which is instrumented to keep track of your vital signs. We did this all the time with the astronauts. You know, we send them up there and we want to make sure they're okay, so they wear clothes with sensors in them. So I got to thinking, well, what if all of our clothes were internet enabled? Well, let's see, if my socks were internet enabled, I could send an interrogation to the sock drawer, and I'd get back a report saying there are 17 matched pairs of socks, except sock number 144L is missing. So I'd send a multicast around the house, and I'd get back a report saying, hello, this is sock 144L. I'm under the sofa in the living room. So now we've solved the problem of the missing sock, and I think that's a really important societal contribution. Now, the problem with these kinds of ideas is engineers don't always think of the consequences of these things. So there's another scenario which is not so good. Suppose that you're at a university and you call home and you say, hello, sweetheart, I'm going to work late in the lab tonight. And there's a brief pause, and you hear the clicking of keys. And she says, well, that's interesting, sweetheart, because your shirt seems to be down at 19th Street at the bar. Think, oh, so maybe internet-enabled clothing is a really dumb idea and we shouldn't do this. That's the internet-enabled sock. Now, if you could stand another 5 minutes, I have a brief report on the status of the interplanetary internet. This is not a Google project, by the way. Our business model is not to take over the solar system, at least unless Eric and Larry and Sergey have something in mind that I don't know about. This is a project that I started at the Jet Propulsion Lab about 8 years ago in 1998. You know, we've instrumented planet Earth pretty thoroughly. We've got overhead satellites, we've got sensors on the surface of the Earth, and we've got sensors in the water to warn us of various things, including tsunamis. And we've also gotten very interested in Mars. We've been landing things on Mars since the 1960s. And in particular, when we were starting to do deep space exploration, we needed to communicate with spacecraft that we sent out there. So we built a deep space network with 70-meter dishes and some smaller 34-meter dishes. You can see half of one on the right-hand side there. These things are in 3 places around the world, in Goldstone, California, Madrid, Spain, and Canberra, Australia. And as the Earth rotates, these dishes can see out into the solar system and communicate with spacecraft like this that are either in orbit around the planet or going past the asteroids, or in some cases actually landing on the surface, like the 1997 Pathfinder mission that landed on Mars and sent back some pretty impressive photography. More recently, we put Spirit and Opportunity on the surface of Mars at the beginning of 2004. These are much larger than the Pathfinder mission. These are 150 kilogram systems that are about 4 feet tall. They're very complex. They have a lot of equipment on board, multiple radios, and they have these solar panels which are used to provide power. One of the things that was surprising about this mission is that it was originally intended to last 90 days. They're still in operation 2.5 years since they landed. And the reason that they're still in operation, in part, is that the solar panels, which are used to charge the batteries, have actually been cleaner or have been less dusty than we expected. Usually what happens is dust accumulates, they become less effective, you can't recharge the batteries. And at one point, during the Martian nights, it's so cold that you have to run heaters to keep the electronics and the instruments functional. And eventually what happens is the batteries don't charge up enough and you can't run the heaters, and then the electronic instruments fail and the mission is over. So these things have lasted for 2.5 years because the solar panels have remained cleaner than we expected. Now, personally, I think somebody's up there dusting them off, but we haven't caught anyone on the video, so it's pure speculation. The real answer is that both the Spirit and Opportunity spacecraft are at places on Mars where there are dust storms that they're like whirlwinds, and they've blown the dust off of the solar panels. And so they simply continue to recharge the batteries very reliably for all this 2.5 years. We've got a few other shots. This is the landing platform that the rover crawled off of, turned around, and took a picture of. And this is a nice landscape of Mars. I've been thinking that you might have a real estate deal here. You know, there's a little hill up on the right there which has a great view of the plains, and you know, you could probably sell that a few thousand times because nobody's actually going to go there for a while. Some business model that would be. The reason I got interested in this, though, has its roots in the internet. When we launched these missions in the past, every spacecraft, robotic spacecraft, has had a different set of instruments on board. And we've tended to tailor the communications protocols to that set of sensors in order to efficiently use the very limited bandwidth that we have available. Typically, we can only get 10 kilobits a second outbound to the spacecraft and maybe 100 kilobits per second coming back. So it's very limited capacity. We've been very careful to tailor the protocols. The problem with that is that it means that every time you launch a new mission, none of the mission assets that are still out there from earlier missions can be used to support the new mission because there's no compatibility. So we asked ourselves, what would happen if we standardized all the communication protocols in deep space? We'd get the same benefit that we get from the internet. So actually, all right, I thought I left out a slide here, but it doesn't matter. What we have wound up doing is developing a set of standards for deep space communication, which allows us to extend the operation of the internet across the solar system. We thought we could use TCP/IP, and we were wrong. It was a momentary lapse. The problem is that the distance between the planets is astronomical. And in the case of Earth and Mars, which are in orbit around the Sun, the distances between the two vary between 35 million miles and 235 million miles. And if you do the math, at the speed of light, it takes a radio signal anywhere from 3.5 minutes to 20 minutes to propagate one way between Earth and Mars. And the round trip time is twice that. TCP doesn't work very well with a round trip time of 40 minutes. I mean, the flow control doesn't work very well. And there's another problem that's called celestial motion. If you're talking to a rover on the surface of Mars, Mars is rotating, and after a while you can't talk to it anymore because it's on the wrong side of the planet. The same thing happens to you with orbiting satellites. So we wound up having to develop a whole new set of protocols for interplanetary communication. We have internet running on the spacecraft, standard TCP/IP. We have TCP/IP running on the surface of the planet, and clearly here. But we use a delay and disruption tolerant networking protocol for interplanetary purposes. So the results have actually been very successful. We've been through 4 iterations, and we just launched this Mars Reconnaissance Orbiter, which has the lower 2 levels of a 4-layer interplanetary protocol system on board. When it finishes its survey of Mars, it will have more of the interplanetary protocols uploaded, and it will become the first node of an interplanetary network between Earth and Mars. As we launch new missions over a period of time, each new mission will have these standard protocols on board and can be used as another node of the interplanetary backbone. So I don't want you to get the idea that we're building an interplanetary backbone and then hoping somebody will come. That's not what we're doing. We're going to standardize the protocols and allow each mission to define the next node of the interplanetary backbone. And I predict that the missions to the outer planets will actually have very long-lived nodes associated with them, because the farther away you go from the sun, the less effective solar panels are. And so we're going to have to use nuclear power when we start sending missions out to Pluto and Uranus and Saturn and the like. And nuclear power plants will last a lot longer than the typical solar panel systems do. So those systems will be in operation for tens of years as opposed to tens of months. As a consequence, I think it's predictable that we will have an interplanetary backbone that will grow during the course of the next several decades. So that's the basic report. Kind of a long one, I know. I hope it's okay that I just rattled on long. How long did I go? I went on hours, an hour and a half. There you are.
Thank you very much, Vint. I think that internet means innovation, and innovation means more money.
I hope so.
Anyway. It has for the last 35 years anyway, hasn't it?
I remember that over 10 years ago, Professor M.B. Simon was São Paulo close conference, and he mentioned that the internet at this time, 94, are in the middle of a storm. The internet is the eye of the storm, and we don't know the direction that the storm will go. And after 12 years, probably we are waiting to see strong race for the future, but innovation always is there, and we are part of the process. Thank you very much. Now we have open for questions. We have some journalists with us. We have university professors. We have lawyers. We have some staff members, some steering committee members. So we are very mixed, and we can have more technical problems or more, I don't know, legal problems or more. Depends. Please. I need to go to my office for 2 minutes. Maybe.
Okay, I have one question here
Sure.
from the internet. Actually, it's from one of our board members from the steering committee. And what he says is, I have to translate. It's from Marcelo Fernandes and Carlos Afonso and Mário Teza, according to the email. And the managing...
Is the question in English or Portuguese?
It's in Portuguese.
So you're translating.
Yeah.
Thank you very much.
I wouldn't be up to answering it otherwise.
Well, it says the internet, Brazilian internet model, the managing model, is a multi-stakeholder one here in Brazil. So the question is, how do you evaluate this model? And what do you think of the the way the Brazilian internet is carried here?
Well, I'm a firm believer that this multi-stakeholder dimension is absolutely essential, and I think we see an example of that here in NIC.br. I mean, if you look at the organizational structure and the oversight
Committee, that it has a very diverse representation from a lot of different sectors. Internet touches almost everything, whether it's the private sector, academia, the government, and the individual members of the population. So I think even if you didn't want to have a multi-stakeholder structure, you would almost be forced into it because of the diverse interests that people have in the internet. We've tried at ICANN to create a framework for multi-stakeholder policy development. I have to say that it's not been an easy thing to do, particularly when it comes to dealing with the public, because it's not clear who speaks for the public. We've tried in the ICANN world to open all policy discussions up in such a way that the public does have access to all the material that we're proposing to make policy out of, in order to obtain feedback from them and from all the other interested parties. I noticed, and I was pleased to see, that in the World Summit on the Information Society, that the structure of the Internet Governance Forum was also multi-stakeholder. It included civil society, the academic sector, the private sector, and governments. And I think that's a healthy design. The thing I do notice, though, is that Internet is infrastructure in the same sense that the power system is infrastructure and the road system is infrastructure. And for the most part, you don't see a lot of individuals wanting to, elect the president of the power company, or, what they want is power to be reliable. And what most people in the internet world want is that the internet works. They want the domain name system to resolve. They want the web pages to be interpretable by their browsers, etc., etc. There are times, though, when members of the public will want to be able to say something about a policy that's being developed. And I'm sure that the NIC.br folks have had similar experiences where the users of the internet, at least some of them, are vocal about their interests and their concerns. So I believe that that we have a pretty good basic formula for multi-stakeholder policy development, and I hope we can continue to exercise that model as ICANN and other elements of the net like NIC.br continue to evolve. So I'm pretty persuaded that that's the right way to do it. That to move away from that into, for example, a purely top-down governmental model, I think would seriously fail to take into account the concerns and interests of all the parties that the Internet touches.
I have a follow-up here.
Yeah.
And so what do you think about the internationalization of ICANN and say the compromises assumed in WCs?
I'm sorry, say again.
And the compromises, you say the commitments taken during the World International, the WSIS.
I'm not sure I fully understand the question.
What they are asking is what you think about the
internationalization of ICANN. That's actually a rather ambiguous question, because there are different aspects of ICANN that one could look at from an international point of view. If you look at the board, I would say it's pretty international in its scope. And we have 21 members. Some of them are voting, some are not. The voting members are from a very diverse community. 2 of them are from Brazil, actually. But as the board has cycled through its membership since 1998, we've covered a fairly significant number of countries. We're also very careful that representation on the board be drawn from all the regions of the world. So from that point of view, I think we've done well. Internationalization sometimes is a code word for somehow separating ICANN from its relationship with the U.S. government. When ICANN was formed, it was actually created at the initiative of the White House in 1998. There were a series of, I won't repeat all the history, but there was a green paper that was proposed and then a white paper that followed after quite a bit of international discussion. And ICANN was identified as the organization that would take responsibility for the top-level domain root zone, internet address allocation, and the like. But there continues to be a direct relationship between ICANN and the U.S. Department of Commerce. And there are some parts of the world that feel uncomfortable that there's only one country involved in that relationship. We have negotiated, the most recent negotiation of that MOU has an endpoint at September 30th of this year. And one of the open questions is, well, what happens after the expiration of that particular MOU? Will it be extended? If it is extended, will it have different terms and conditions? Will there be other parties besides the United States involved? And I honestly don't know the answer to that. If I had a choice, to be quite honest with you, I would rather go from 1 to 0 than from 1 to N when it comes to oversight by government. And the reason that I would prefer that, frankly, is that as soon as you get multiple governments involved in something, you run the risk of politicizing all of the policy making that's going on. And the limited policy making that's needed, you politicize it, and I'm fearful that that will actually harm the interests of everyone in making the internet work well. On the other hand, going from oversight by one government to 0 has its risks. Somebody has to make sure that we're not doing the wrong thing, and I can. To go from 1 to 0, I think, requires us to become increasingly transparent. That is to say, everything we do has to be very clear, so that there is, in a sense, oversight by everyone. And so you can see increasing efforts to increase the transparency of the deliberation processes, all the budget making, all of the other decisions that are made by ICANN are increasingly offered in a public forum. And I think if we can continue along that track, that we might be able to persuade everyone, including the U.S. government, that it could safely step away from its current role. and allow ICANN to operate more or less independently. I absolutely cannot predict how that will come out between now and the end of September, but that would be where I would like to end up. Yeah. It's okay. You guys can duke it out if you like.
As you have referred, VoIP is already influencing on the market, on business models through the traditional telephonist business model. What do you think will be the role of ITU and ICANN in terms of governance in the near future?
Well, ITU, of course, has a long history. It started out as the International Telegraphy Union in the 19th century. And then when telephony was invented, it became the center of international cooperation for telephony. It has been, its origins were largely based on the fact that most telephone services were offered by governments. And in past history, it was very common for the government to offer postal service, telephone service, and the like. That isn't always true. In the U.S., it tended to be, for telephony, it was actually offered in the private sector, but the postal service was offered by the government. The Internet has introduced a pretty disruptive technological framework in which these various services are now offered. In a sense, almost obviates the need for a telephony authority, because it's simply another thing that you can do as an application on the net. Peer-to-peer applications, Skype being a perfectly good example of people downloading software and talking to each other over the network. It's also clear, though, that there is a component of the traditional telephony world which has been growing pretty rapidly, and that's the mobile telephony world. And so, in a sense, that's not going to go away anytime soon. So I think there has to be some relationship between ITU and ICANN, in the sense that there is a relationship between the public switch telephone net and the Internet. And the two parties clearly have responsibilities that are parallel, although they're in different networking environments. I would expect that there would be continuing interaction between the two organizations. For example, Voice over IP has included in it a notion of what's called enum, and I know you're familiar with that, and it's the ability to make reference by telephone number to something that's on the Internet. If you've migrated your telephone instrument from the telephony world to the Internet, you might still want people to be able to reach you by dialing a telephone number. So enum lets you do that. And we've cooperated with the ITU to make that happen. I think the ITU members and the organization itself have encountered difficulty in the last several years because the telephone industry itself has been changing. The motion towards mobile is one strong element. The revenues associated with traditional wireline telephony have been actually declining. The international settlements element has also changed and been declining over time. So I think the ITU has been visibly trying to reinvent itself in the presence of this new Internet environment. I think it's probably not credible, however, for it to attempt to reinvent itself to the point where it can credibly supplant the functions that ICANN performs, since ICANN is made up of the community that essentially invented and operates the Internet. So I think that ITU will still have a role to play, but, and I'm plainly biased in my opinion here, but I don't believe that it can credibly argue that it should pick up the responsibilities that ICANN currently fulfills. And I think if you try to go back and start all over again, as some people have thought we might need to do to reinvent ICANN, what you'd end up with are exactly the same parties having exactly the same discussions, ending up with exactly the same structure that we have today. So I think my advice here is to continue to improve ICANN's operation, build on the base that we have, work cooperatively with the ITU in areas where there's plain overlap of interest, and to see how things evolve. As Hartmut points out, we don't know how all this is actually going to turn out. All we know is that there is this continuing creativity and evolution of the technology of the internet and the applications that it supports. One over here and then here. Yes.
Then, with all of these questions, the internet is working well. And in my point of view, the internet is the best tool to help develop the small and medium enterprises to make competitive. In your point of view, what do you think, what ICANN and the Brazilian Steering Committee need to do to help this?
Okay, I'm not sure I heard every part of the question, and so I'm having trouble answering it. Hartmut, can you help me just a little bit?
My understanding was that the internet is a tool for small and small entities to improve the
Small businesses.
Small business.
Okay, yes.
To improve the competition.
Yes,
What
okay.
can ICANN and the
Yes.
Brazilian Steering Committee do to support this?
I'm a huge believer in small business development, but my impression right now is that the internet is very accessible to small businesses. You must be doing this here. People register domain names in order to make themselves visible on the network and in order to build businesses that are visible more than just domestically. And in fact, one of the things that you have a special situation here in Brazil because you have a pretty good size economy. And so small businesses here can often build their business models on the assumption that they will serve only a domestic market. There are other parts of the world, though, that have island nations, for example, that have limited populations, limited domestic markets, and they need to organize their businesses around international services because they can't necessarily build a sustainable business only in the domestic market. Internet is a really powerful tool for delivering products and services that are digital to parties outside or to at least making visible products and services that might have to be delivered in the physical world. I don't know whether I'm getting to where you want to go here.
Yes, because I normally say names and numbers for what? Or names and numbers for
So this
for a business, and we don't talk nothing about this in ICANN, in the steering committee. We don't have the value what I think to need to put in this.
Okay.
What we can do.
So actually, this is a discussion that Bob Kahn and I have had more than once, and that is the question of what things should be identifiable in the internet, and what things should have a domain name, what things should have an internet address. In fact, it is becoming more and more apparent that the virtual digital objects of the internet probably should not be bound to an internet address or to a domain name. Because domain names are synonyms for physical places in the net right now. And hosts in particular, at least that's how it works right now. You take a domain name with a URL, you take a domain name, translate into an internet address, you go to a physical place on the net, and then you say, where's the file that URL refers to? Bob makes the argument, which I find pretty persuasive, that we should have identifier spaces that are absolutely independent of the underlying infrastructure of the network. And that we can use resolution methods not unlike the domain name to find those virtual objects, but that we don't want them ever to be bound by name or by identity to any particular place in the net. So he's developed a system that he calls the handles system that uses digital object identifiers that are purely virtual. They have the property that they're intended to persist for hundreds of years. Now this raises another problem, and so if you'll forgive me for going down this path just a little bit, now that you've opened the door, we have a problem collectively with digital information. Every time you store a document in Microsoft Word or a spreadsheet or something else, you implicitly are requiring the storage system to help you find the software that lets you interpret that document. So suppose, for example, that we have been storing all of our PowerPoint, I don't mean to pick on Microsoft, it's just a convenient example, but suppose you've been storing your PowerPoint since 1997. And one day you say, well, I have to go look at that old PowerPoint presentation, and you pull up the document and you try to look at it using the latest version of Microsoft software, and it doesn't know how to read it. And this is not a complaint about Microsoft. I mean, at some point you have to say, I'm not supporting this anymore. But if you want information to have any kind of lifetime at all, we're going to have to retain not only the application software that lets you understand the document and manipulate it, but maybe even the operating system that that application was designed to run on. Nobody's doing anything about that right now. And so hiding behind this tidal wave of digital information is a really big problem, making the information interpretable over a really long period of time. So this gets back to the notion of the longevity of the identifiers of these things, requiring infrastructure to make it possible for us to actually use the old information. And I honestly don't see any current organizing principles that will allow us to do this easily and effectively. I just don't know the answer to this, other than to suggest that the software that's needed to understand the documents that we're storing away had better be on the net, because they probably won't be in the laptop. I doubt that anyone retains old versions of software after they've done an upgrade. And at some point, the backward compatibility is going to fail. So it's a really interesting problem that you've just uncovered. And there may be some PhD dissertations hiding in these problems for somebody to solve. You have a question.
My name is Manuel Fernandes.
Good morning.
Good morning. And I'm editor-in-chief of the R&T magazine from Quest XP, United States. I have two questions about business. What do you think about the Google success? What's the reason? And what do you think about the computers, low-cost computers, like the Nicholas Google project?
Yes.
MD.
Okay. Actually, Nick was in Santo Domingo with me over the weekend, and we both had a chance to talk about the One Laptop per Child project. So let me take Google first. It's been a phenomenon, and I think that the simple fact is that this avalanche of information that flowed into the net after Tim Berners-Lee's World Wide Web was introduced by way of Netscape Communications and Mark Andreessen's Mosaic software. There's some sociologically interesting things here. One of the reasons so much information came onto the net once the World Wide Web was released is that every browser had this little feature called View Source, which meant you could look at the HTML that was used to produce a web page that you thought was interesting. People learned by example. It was a phenomenon. Webmaster was a title that didn't exist until 1992 or 93, and these were persons who looked at the HTML web pages and copied them and then learned how to make them even more elaborate. So there was a huge avalanche of information flowing into the net after that point. Of course, that led to the problem of finding things in this increasing amount of data, and that's where search engines came along. And there were several of them, as I'm sure you know from history, things like Gopher and Wide Area Information Service, and then Alta Vista, and increasingly clever schemes for crawling through the web pages and doing indices were developed. And I think the reason that Google was so successful is that the relevance of its responses to a search seemed better to the users than any other search engine that had been invented up to that point. And of course, Google continues to work very hard on the search algorithms that it uses. One of the things that I think contributes to Google's success, of course, is that it has a business model that actually supports the cost of doing these searches. I can tell you that this is not a cost-free thing. In order to implement the advertising business model, Google's system has to be extremely fast. And the reason it has to be so fast is that you need to give the impression to the user that when the search page comes up, that it was sort of all there and pre-computed. But I guarantee you it's anything but that. It's being done in real time, including the advertising. And we pride ourselves and we measure ourselves on how quickly we can complete the search and how quickly we can perform the other functions that compose a web page coming back from the search engine. This is an extremely important parameter for us, because if we can't do it quickly enough, the whole process becomes inadequately responsive. People become impatient. They don't like to wait for web pages to come up. They want it all to happen quickly. The reason I emphasize this is that when you see the paid advertising coming up on the right-hand side of the page, it looks like it's instantaneous. And you see at the bottom, or somewhere, it will say that it took 0.018 seconds to do a search through 6 billion items. There was actually an auction taking place to figure out which of the advertisements should be put on the page and in what order. And that was taking place at the same time that we were doing the algorithm to figure out which of the responses to the web search should be put up and in what order. So all this stuff is going on currently, and then bam, the web page comes up. So we build our own computers at Google. We don't buy them off the shelf. And the reason we do that is that it's actually cheaper for us to build them ourselves than it is to have somebody else build them for us. We build our own backbone network. And the reason we do that is it turned out to be cheaper to do that than it was to buy service from somebody. Now, we do buy a lot of service, and that's to get access to the public network. And so we pay quite a bit to have very broadband access so we can interact with the people who are making queries or who are doing their Gmail or who are looking at Google Earth and Google Maps. So there's a big expense associated with all this. The only reason it's worked is that the advertising model has been sufficiently relevant to the consumers that it has made the advertisers happy. That is to say, they see sales go up because they see consumers buying their products because they found out about things in the Google ads. So that's not something which is guaranteed at all. You have to work really hard to make that happen. So while Google does welcome all the competition that it has, it's also working harder than ever on improving its algorithm. So we have more people working on search quality now than we ever had in the past. Of course, we only had 2 people to begin with. That was Larry Page and Sergey Brin. We now have a lot more people. There are about on the order of 7,000 people working at Google now. And a number of them are outside the United States. So this raises one other response to the question of Google's success. Google is very committed to trying to make the search and other applications relevant in each geographic area where it's operating. So we recognize that there are cultural differences and, of course, language differences around the world, and our products and services are being localized, which is why we're hiring people from different countries. Part of my job is to visit every engineering office that Google opens. Yes.
One more question. What's Google? The search company or advertising company?
I'm sorry?
What is Google? Is a technology company or advertising company?
Well, it's a company of engineers, for one thing. I mean, it's at least half engineers. And it is clearly an advertising company because that's where it generates its revenue. There's no question about that. But it is an engineering company in the sense that almost everything that happens is driven by engineering ideas. There's a management scheme at Google which I find absolutely unique. The engineers are given essentially a 70-20-10 rule to work by. 70% of the engineering time is on projects that you've been assigned. 20% of the time is on projects that have been assigned to other people that you're interested in. And if the other people let you work on them, you're allowed to do that. 10% of the time, the engineers are allowed to do whatever they want to do. Yeah, because they're going to do that anyway, so we just build that into the model. an amazing number of new products and services come out of that 10% time. I mean, Google Earth was one engineer's 10% time project. He discovered a company called Keyhole and got very excited about the potential that the Keyhole imagery system could play in our advertising model. So we don't make any assumptions that Google's success is already preordained. It's a lot of work to continue a successful operation like this. We're certainly becoming more and more involved in different media, and we're very involved in providing more network-based applications. So you've heard about Rightly, which is our shared document editing system, and more recently there is a shared spreadsheet which we've put up and announced just in the last couple of days. Your second question was?
Nicholas Negropont. Nicholas Negropont, and what's your opinion about the computers low cost?
Oh, the low-cost computers, right. So I talked to Nick about this. Nick Negroponte, I think correctly, believes that unless you have access to a laptop or a computer all the time, whenever you want it, that it simply won't be a very useful tool for you. I mean, imagine, let's see, what if we projected ourselves back to 800 AD and the Chinese have just invented paper? But it's really expensive. And so we recognize that this is a tremendously powerful tool and that people should learn how to use paper. But it's so expensive that we decided that in the elementary schools we're going to have paper training classes for 15 minutes a week. And so for 15 minutes everybody gets to have a sheet of paper and a pencil, and you can practice writing on the sheet, and then we put it away. And then 15 minutes the next week you get to try this out again. So are we going to wind up using paper effectively as a tool? Well, the answer is, of course not. Paper is only useful if you can take it whenever you need it and write on it and keep it. So that's true for computers as well. So Nick's theory, which he would probably express better than I do, is that the kids should essentially own the laptops. He also noticed one other thing that I didn't know about. Setting aside the cost, which we're trying to drive down. By the way, Google is investing in this too. We put $3.5 million into the project. We have, 10 engineers that are working on this with the rest of the team to do the design. So we were very committed to this. But he made the following observation. When you put computers into a classroom and it's a shared asset that everyone gets to use, they don't last very long. They kind of last 3 months and then something bad happens. And it's not because the kids are willfully damaging it, it's just that they don't care for it. I mean, when was the last time you washed a rented car? You never wash a rented car. Right? So the kids own the laptop. It's like the vegetables. That's my carrot. I'm going to eat that. If that's the kid's laptop, they treat these as their property. They're very careful with them, and they last for as long as they last, except maybe if something breaks. But the kids are very, very protective of those because it's their computer. And so we want that sense to be very deeply ingrained in the kids, that that's their machine to use. If you have laptops, and I bet every one of you do, you probably are pretty protective of that. It has a lot of information, you've invested a lot of time and energy in the contents of the laptop. You don't want to lose that. You don't want the laptop to break because you really want it when you need it. So that's what we're trying to do with this one laptop per child project. But it is not enough simply to supply the laptop. I mean, first it has to have software, it has to have content. The power problem, by the way, has been solved in a very interesting way. We recognize that these kids are going to end up in places where you don't plug into the wall and get power. So we've got hand-cranked generators. The crank is connected to the power supply, not to the laptop. We actually tried the laptop thing, and it was awkward. Right? It broke off and all this stuff. So now we got hand cranks, we got foot pedals, we have solar panels. Anything that will move an electron, from point A to point B, is fair game to power these computers. So I'm a big fan, obviously, of getting these things out there. But we need the rest of the infrastructure. We need teachers who are comfortable with the equipment. We need content that can be used in the classroom. What Nick noticed, and I think we've seen in other contexts, is regardless of the language, kids are amazingly able to absorb and learn how to use things. You don't have to show them very much before, and they try stuff out. They're not worried like adults are that, oh God, I'm going to break it. The kids just try things. They're very comfortable with this. So I'm very excited. I hope that we make this a very successful project. Yes, ma'am.
According to the World Economic Forum, Brazil has lost several positions in the economic society, as I say. At the same time, Brazil is number one community in Orkut. You're familiar with that. Which kind of specific opportunities do you see for Brazil in the internet model, business model? And the second question, since I'm a journalist, I would like to know what's your opinion about the blogs? Are they really democratization of society information?
Okay. With regard to Brazil's position in this whole IT area, actually the experts are not me. They're sitting here in the room from NIC.br. But the data that I've seen so far says that we probably need to work harder to get more internet access out, especially in the rural parts of the country. But I see strong evidence from the universities that I visited that there's no reason not to imagine a stronger and stronger IT business arising in this country. The thing that I don't understand fully and would want to know more about is the nature of the domestic economy and the role of IT, and whether or not a large number of businesses can be sustained strictly domestically, or whether you have to configure for international operation. I know that in other countries like New Zealand, where the economy is limited, I've encouraged them to think about serving populations outside of the country. Ireland and India have both done that very successfully, and those were national decisions. The Indian government decided in the early 1980s it would invest in IT with the sole purpose of exporting the expertise. The Irish did the same thing. They were in an especially good position because their economy was sufficiently weak compared to the other countries of the then European Union 20 years ago that they actually got more money back than they put in. And they invested it in information infrastructure, broadband optical fiber connections to Europe and the US, more training for engineers and computer scientists, and to attract businesses. And in fact, they've attracted business. Our largest European operation is in Dublin. There must be 700 people there from 37 countries speaking 42 languages. I mean, you walk in there and it's like a little United Nations. It's amazing. So I think that Brazil has shown evidence that it can produce some of the best quality computer science and IT productivity. And we bought Aquan as an example of that, and there's already stuff going on at UFMG that's, did I get that right? Is it you? I forgot the initials of the university in Minas Gerais. UFMG.
Yeah. Aquan.
The universities federal of Minas Gerais.
So, and I visited the University of Sao Paulo as well. So there's every evidence